Hi students, in this class we will learn about relation between current and drift velocity. I is equal to NEAVD. In our previous class we learned about drift velocity. Here we will learn about the relationship between electric current and this drift velocity. To derive the relationship between electric current and drift velocity, you have to consider a conductor of length L and area of cross-section A. Connect this conductor to a voltage V. When a potential difference is applied, electric current starts flowing in the conductor. Let A be the area of cross-section of the conductor and L is the length of the conductor. Then what will be the volume of this conductor? Volume is A multiplied with this length. AL will give you the volume of the conductor. Let N be the number of electrons in this conductor. And small n is the number of free electrons per unit volume. This small n is also known as number density. Small n is equal to capital N divided by AL. Capital N is the total number of electrons in this conductor. Small n is the number of electrons per unit volume. Therefore, what will be the total number of electrons? N. Total number of electrons will be N multiplied with this AL. Therefore, capital N is equal to NAL. What is the basic expression for electric current? Electric current I is equal to Q by T, where Q is the total charge. If E is the charge of an electron and if there are n electrons, what will be the total charge? N into E. This is the total charge of the electrons. Here we are not taking the negative sign. We are considering only the magnitude. Therefore, I is equal to, in the place of Q, you can write NE divided by T. We already learned capital N, the number of electrons is small n into volume A into L. Replace this n with this value. Therefore, I becomes I is equal to N A L E divided by T. Charge Q is equal to NAL E. This is the total charge. Current is the rate of flow of charge. Therefore, electric current I is equal to NAL E divided by T. What is this T? T is the time taken. You look at this diagram, the total length or the distance is L. Time taken T is equal to distance or displacement divided by velocity. Here the velocity is drift velocity. Therefore, time T is equal to, in the place of displacement or distance, you can write L because L is the total length of the conductor. Divide L by Vd. T is equal to L by Vd. In this place, you can substitute this value. Therefore, I becomes I is equal to N AL E divided by L by Vd. Cancel this L and I is equal to N A E Vd. This is the expression for the electric current and drift velocity Vd. Time taken T is equal to displacement divided by velocity. Displacement or distance is L. Velocity is the drift velocity Vd. Therefore, I is equal to NAL E divided by L by Vd. which is equal to NEAVD. In this session, we learned to derive the expression between electric current and drift velocity. The expression is I is equal to NEAVD, where N is the number of electrons per unit volume, E is the charge of the electron, A is the area of cross-section of the conductor, and VD is the drift velocity. The electric current I is equal to NEAVD. This is the relationship between electric current and drift velocity. Hope you understood this session. See you in the next class.